You've opened the Engineer's Grimoire, a field manual for banishing circuit gremlins and keeping the magic smoke where it belongs, forged in solder and bound by mystery. Once whispered about in dimly lit workshops and passed between those who dared to build beyond the veil, this is your handbook for surviving the technical unknown. I'm Rachel DeBarros, your guide, witch of the workbench, and keeper of the grimoire. Each episode will turn a new page to explore the tools, wiring, and code you'll need to bring your Arduino-powered creations to life and keep them from turning into cursed artifacts. This is engineering with a touch of the arcane. Before we begin today's ritual, or lesson, just a reminder, you can find all the wiring diagrams, pinouts, code, and extra tools from this episode over at racheldebarros.com. Go check it out after this episode. It's like finding the digital Necronomicon, but instead of summoning demons, you summon working circuits. Today, we're conjuring one of the most fundamental spells in your electronic arsenal, the blink. Yes, it's simple. Yes, it's just an LED. But like all ancient rituals, it starts with a flicker. The ritual of light. There's something oddly satisfying about bringing a tiny light to life. It starts as a cold, lifeless component, just two little metal legs and a colored dome. But the moment you wire it up and cast the right code, it blinks awake, like it's watching you. You've seen them before. Tiny glowing dots in haunted props, blinking eyes in jack-o'-lanterns, the occasional cursed mirror with a heartbeat of red. And let's be honest, if you've ever built a spooky Halloween prop, you've probably reached for the red ones first. Why? Because nothing says ominous like glowing red eyes staring at you from across the room. They're the first building block in your journey as a circuit conjurer. And today, I'm going to teach you how to make one blink. But let's back up. What is an LED? LED stands for light emitting diode. Think of it as a one-way gate for electricity that glows when current passes through in the right direction. But here's the trick. Like many ancient symbols, it has polarity. That means you can't just plug it in any old way and expect it to work. You've got to get the direction right, or your spell fizzles. So how do you tell which end is which? Your LED has two legs, one longer than the other. The long leg is the anode, or the positive side. The shorter leg is the cathode, the negative. But what if those legs have been snipped? If you're digging through your parts bin and someone, possibly past you, already trimmed them, no worries. Take a close look at the LED casing. Along the rim, you'll often see a flat edge on one side. That's the cathode, the negative side. Kind of like a secret mark burned into an artifact, a subtle clue for those who know where to look. Still unsure? Here's a little test you can do. No ritual circle required. Grab a 3-volt coin battery and place the LED legs on either side of it. One leg on top and one on the bottom. Doesn't light up? Flip it around and try again. If it lights up, bingo, you found the right orientation. If it still doesn't, sorry, my apprentice, that one's a dud. Happens all the time, especially when you buy a sack of LEDs in bulk. There's always a couple of lifeless souls in the bunch. Once you've identified the anode and cathode, hold on to that knowledge. We're about to summon our first working circuit. Wiring the sigil. So now you've uncovered the secrets of the LED, its hidden polarity, its glow or no glow personality, and how to spot a dud among the bunch. Time to bring that little minion to life. In this chapter, we'll wire up a simple circuit, one of the most essential you'll ever use. It may not summon spirits or open portals yet, but it's your first real step into hands-on hardware enchantment. Let's summon our components. A red LED, a 220 or 330 ohm resistor, a breadboard, 2 jumper wires, an Arduino Uno, and a USB cable to upload code and power the ritual. Let's talk breadboards first. This little rectangular plastic slab with rows and columns of holes, think of it like a reusable spellcasting slab. It's where you place your components without soldering them permanently. The central section is made up of vertical columns of holes. Each hole in a column is electrically connected. So if you plug 2 component legs into the same column, you're joining them together. If they go into separate columns, they're electrically isolated. That's important. Along the top and bottom edges of the board, you'll see 2 long rows. These are called power rails. One is marked with a blue line for ground, and the other is marked with a red line for positive voltage. They're especially handy when you need to power multiple components from the same source, like lighting up an entire army of LEDs or animating a prop with motors and sensors. But first, you must master the one before commanding the many. Now, pick a spot and insert the LED. Anode leg in one column, cathode in another. Each leg must go into its own column to keep them separate. Let's tame the energy next. LEDs are fragile little sprites. Give them raw power straight from the Arduino, and poof, they're gone in a flash. That's why we add a resistor, to control the flow of current like a magical dam holding back a flood. Use a 220 or 330 ohm resistor. These are good default values for LEDs in 5-volt systems like the Arduino Uno. Boards like the ESP32 run at 3.3 volts, and these values still work just fine. Now here's something most beginner conjurers don't know. It doesn't matter which side of the LED the resistor goes on, positive or negative. The important thing is that it's in the path. That said, most schematics and builds put the resistor on the positive or anode side, so that's what we'll do. Take one end of the resistor and insert it into the same column as the anode leg of your LED. That's the long leg, the positive side. This joins them together in the circuit. Now, we need to eventually connect the second leg of the resistor to the Arduino, our enchanted power source. Depending on where you placed your LED and resistor on the breadboard, that leg might be close enough to reach a pin on the Arduino directly. But more often than not, you'll need to use a jumper wire to complete the path. But, and this is important, don't plug both legs of the resistor into the same column on the breadboard. That's like casting a portal and sealing it with bricks. Magically pointless. Or, for the less arcane among us, it's like putting both feet into one pant leg. You're going nowhere. Unless you're eerily good at hopping. Instead, place the second leg of the resistor into a different column nearby. If you're working on a full-size breadboard, you can even jump it across the center trench. That horizontal dip in the middle that splits the board in two, that trench isn't just decorative. It's electrically isolated, like a cursed ravine dividing the living from the undead. By hopping the resistor across, you give yourself room to spread out the rest of your components and avoid shorting the magic. Once that leg of the resistor is safely placed in its own column, Connect a jumper wire from that column to pin 13 on your Arduino. Now pin 13. That one's legendary. It's the chosen one, the only pin on the Arduino with a built-in LED hardwired to it. So even if your external circuit isn't connected, any spell you cast through pin 13 will light up the board itself. That's the positive side of our circuit complete. Now let's ground this magic. Take your second jumper wire and connect the cathode leg of the LED, the shorter one, or the one with the flat spot on the case, to one of the ground pins on the Arduino. There's more than one ground pin on the board. Doesn't matter which one you use, just pick the one that's most convenient for your layout. And with that, your circuit is complete. You've just assembled your first working spell circle. Tiny, unlit, but full of potential. The code incantation. Now that your hardware is ready, it's time to cast the actual spell. And in the world of Arduino, that means code. Every microcontroller needs instructions, something to tell it when to act, what to control, and how often to perform a task. Without code, your board is just a pretty paperweight with a fancy light show built in. But with the right words, you're not just programming, you're invoking power. So let's walk through your first sketch. That's what Arduino programs are called, sketches. And the one we're conjuring today, it's a classic, the blink. When you first launch the Arduino IDE, your spell book, if you will, it opens a new sketch automatically. You'll see 2 blank code blocks already waiting for your incantations. One labeled void setup and one labeled void loop. These are the 2 sacred sections of every Arduino sketch. The setup block runs once, like the lighting of candles before the ritual. And the loop block repeats endlessly, your spell casting forever until the board is powered off or reprogrammed. Let's start at the top. The first part of the code, or setup, reads like void setup, open parenthesis, close parenthesis, open curly brace. Now don't worry, you don't have to memorize punctuation, but I'll explain each part as we go. The keyword void tells the Arduino that this function, called setup, won't return any value. It's just a chunk of code that runs once when the board powers on or resets. Inside the curly braces, we type in our one-time setup instructions. The first command we need is pinMode, open parenthesis, 13, comma, the word output, in all caps, close parenthesis, semicolon. Here's what's happening. The pins on the Arduino board are like magical conduits. They can either act as inputs, which receive signals, like listening to a sensor, or as outputs, which send signals, like lighting up an LED. The Arduino needs to know how we want each pin to behave. So in this case, we're telling it, hey, that pin the LED is connected to, pin 13, we want it to act as an output. You'll be sending electricity through it. We do that with the pinMode command. In other words, we're setting the operating mode of the pin, hence the name. The pinMode command always needs 2 pieces of information to work. The first is the pin number you're referring to, in our case, 13. And 2, the mode, either input or output, spelled in all caps. So again, that line of code reads pinMode, open parenthesis, 13, comma, output, close parenthesis, semicolon. And that's it. Pin 13 is now ready to control our LED. The closing curly brace for the setup function should already be in place in the line below, so the setup is complete. Now that we've prepared pin 13 to act as an output, it's time to breathe life into the loop. This is where the action happens. The loop is the heart of your sketch, the repeating ritual that runs over and over and over again. It starts as void loop, open parenthesis, close parenthesis, open curly brace. The first thing we want to do inside the loop is command the LED to turn on. To do that, we use a spell called digitalWrite. Just like the pinMode command we used earlier, digitalWrite needs two pieces of information. The first is, which pin are we working with? And two, do we want it to send out voltage, which is the word high spelled in all caps, or not, which is low in all caps. So here's our first line of loop code. digitalWrite, open parenthesis, 13, comma, high, all caps, close parenthesis, semicolon. Let me break that down. digitalWrite tells the Arduino to send a signal to a pin. Pin 13 is where our LED is connected. And high means send the full voltage. If you're using an Arduino Uno, that means 5 volts, just enough to wake your LED from the darkness. So at this point, your LED turns on. It starts glowing, watching, waiting. But now we have to decide, how long should it stay on? For that, we use the delay command. This is like putting your program on pause for just a little while. Here's how it works. Delay, open parenthesis, 500, close parenthesis, semicolon. The number inside those parentheses is in milliseconds. So 500 milliseconds, that's half a second. This tells the Arduino, pause the spell, wait half a second before doing anything else. Now that our LED has had its brief moment in the spotlight, it's time to shut it down. We'll use digitalWrite again. Same structure, same pin. Just flip the voltage off. So the line becomes digitalWrite, open parenthesis, 13, comma, low, close parenthesis, semicolon. Low tells the Arduino, stop sending power, cut the flow. The LED goes dark again, hidden, silent. And then another pause. Delay, open parenthesis, 500, close parenthesis, semicolon. Same as before, half a second of silence before the light returns. That's it. Those 4 lines inside the loop give us a simple, steady blink. digitalWrite to turn the LED on, delay to wait half a second. digitalWrite to turn it off, delay to wait half a second. Then the Arduino jumps back to the top of the loop and does it again, and again, and again. Forever. Or at least until you unplug the board. It's more than just code. It's a rhythm, a pulse, a heartbeat in the void. Congratulations, Conjurer! You've cast your first complete spell in the language of machines. This blink spell may seem humble, just turning a light on and off, but it's your proof of life, your first working ritual, a sign that your components, your wiring, and your code are all in harmony. From here, you can modify the pattern, make it blink faster or slower by changing the numbers in the delay commands. You can even use it to blink out Morse code. But for now, let this be your first successful summoning. Your board is alive, the LED responds to your will, and your journey into hardware sorcery has officially begun. So that's today's entry from Engineer's Grimoire, another revealed page from the handbook that wards off the chaos that haunts your circuits. guides your soldering hand, and teaches the practical magic behind electronics. Today, you unlocked one of the oldest and most sacred spells in the engineer's arsenal. You learned what an LED really is, how it only glows when the current flows the right way. You discovered how to read its polarity, tame its power with a resistor, and complete the circuit on the breadboard without summoning smoke. And you wrote your very first looped incantation, one that makes light flicker from the void using nothing but code and willpower. If you want to build this project yourself, head over to racheldebarros.com. You'll find wiring diagrams, code, and more beginner-friendly projects waiting for you, like spellbooks on dusty shelves. Enjoyed this episode? Don't forget to subscribe, rate, comment, and share Engineer's Grimoire with your fellow builders and circuit sorcerers. You never know who else is out there, staring at their breadboard, wondering why the LED won't light. Until we blink again, keep your outputs high and your hauntings low.